Good morning, students. Today we will start our new chapter, sampling theory. So before solving the examples, we required some technical terms here, and the terms are population, the collection of all the observations under statistical investigation is called population, and the subset of population is called sample. Second term is statistic. Any function of the random variable consisting of a random sample is called statistics, and the corresponding characteristics of the population is called parameter. Then null hypothesis. Assumption about a population that we wish to test is called null hypothesis, and the conclusion we accept when the sample data fails to support the null hypothesis is called alternative hypothesis. We will denote the null hypothesis by H0 and alternative hypothesis by H1. Type 1 error and type 2 error. Rejecting the null hypothesis when it is true is called type 1 error. Accepting the null hypothesis when it is false is called type 2 error. Level of significance. The maximum probability with which we are willing to risk type 1 error is called level of significance. Large sample and small sample. If sample is of size n greater than or equal to 30, it is called large sample, otherwise it is called small sample. So these are some technical terms which we are going to use when we are solving examples on sampling theory. So in this chapter, first we will start with large samples. I have already defined the technical terms, so we will see how to test the mean for large samples. So there is a procedure for testing any hypothesis. So first step is define H0. H0 we are using for null hypothesis. Then define H1, which is alternative hypothesis. Then find the test statistics, fix the level of significance, and conclusion if the calculated value is greater than tabular value, we will reject H0. Now in this case here, first we will test of means for large sample. Let mu and sigma square be the mean and variance of a population from which a random sample of size n greater than or equal to 30 is drawn. Let x bar be the mean of sample. Then we are using a formula z equal to x bar minus mu divided by sigma by root n. Important note, if the standard deviation sigma of the population is not known and if the sample size n is large means n greater than or equal to 30, then we use standard deviation s of the sample in place of sigma. Students, we have a question. Sir, define all these terminologies, but what are the use? Why we are using that? So see this example. A tire company claims that the lives of tires have mean 42,000 kilometer with standard deviation of 4,000. A change in the production process is believed to result in better product. A test sample of 81 new tires has mean life of 42,500 kilometers. So test at 5% level of significance that the new product is significantly better than the old one. So students, here the population is the lives of tires. Means one tire company is there, and from that company manager or owner wants to check the lives of the tires. So here company claims that the mean lives of tires is 42,000 kilometers. Now he wants to check that. So for this purpose he selected a random sample of 81 tires whose mean is known. So I have to check whether this sample supports the mean of the population. So given things are, so mean of population is here 42,000. Standard deviation of population is 4000. Sample size is 81. Mean of sample is 42,500 and level of significance is 5%. Now we have to check here. So in this we are using null hypothesis and alternate hypothesis. So null hypothesis is the lives of tires mean is 42,000 km. That is H0 is defined by mu equal to 42,000. And alternate hypothesis is it is not 42,000. So we have to check it. So formula Z equal to x bar minus mu divided by sigma by root n. Here x bar is 42,500 minus 42,000 divided by sigma is 4,000 divided by n is root 81. So calculations gives us the value 1.125, which we call Z calculated value. Now level of significance is mentioned here. So at 5% level of significance, tabulated value of Z is 1.96. And also here Z calculated value is less than Z tabular value. So we accept H0. So accepting H0 means there is no improvement in the lives of tires. Now second example. Can it be concluded that the average lifespan of an Indian is more than 70 years? If a random sample of 100 Indians has an average lifespan of 71.8 years, a standard deviation of 7.8 years. Students, in sampling theory, in my videos, I am going to use 2 tail test only. I am not going to use 1 tail test. So any problem you can solve using both the test. So here you may think that the population mean is more than 70. So we will consider suppose population mean, that is null hypothesis is mu equal to 70 and alternative hypothesis is mu is not equal to 70. So null hypothesis states that the average lifespan of an Indian is 70 years. So given things are mean of population 70, number of elements in sample 100, mean of sample 71.8, and here standard deviation of sample is given. So sigma equal to S equal to 7.8 because of we have already written one note. Now using all these things in the formula, Z equal to x bar minus mu divided by sigma by root n. X bar is 71.8, mu is 70, sigma is 7.8 and n is 100. So this is 2.30. So Z calculated is 2.30. Now in this example, level of significance is not mentioned anywhere. So you will consider level of significance to be 5%. And from table at 5% level of significance, tabular value of Z is 1.96. So here calculated value, which is 2.30, is greater than tabular value, which is 1.96. Therefore we reject H0. And rejecting H0 means the average lifespan of an Indian is not 70 years.